Bienvenidos, ushamti, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 Certification Exam Preparation course, and in this tutorial, we're going to be doing a quick supplement here on Lab 6.2.7. Again, a lot of moving parts in Lab 6.2.7, so we want to break them down, make them a little bit easier to understand. And we're getting ready to dive into building a Docker container. And so what we're going to do here is we're going to take a look at a super simple example so that we've got a really nice, easy walk up to part 5 in Lab 6.2.7, where we're actually going to be incorporating our Python application into a Docker container. But I want to go over a few things with Docker before we dive into that to make the syntax and the steps a little bit more understandable. So let's go ahead and jump over here. We are on the DevASC virtual machine. Again, you don't have to be on the DevASC virtual machine to do what I'm going to do here. However, let's take a look at a very simple Docker file. Now, what is the Docker file? Here's what I want you to think of the Docker file as. Think of it as the recipe to build your container cake. Right? So if we go to build a cake, we're going to need eggs. We're going to need lots of sugar. We're going to need flour, right? We're going to need a lot of ingredients. And that's what the Docker file describes, right? The Docker file is the recipe for how we're going to build our container. So let's take a look at this Docker file that we have right here. And you'll notice that it's in this directory. I created this directory test just off of the sample-app directory so that we don't cause any problems in that sample-app directory. And here is a super simple Docker file, and here are my ingredients, right? Now, we've got some statements in here that you're going to see, and sometimes these can cause a little bit of confusion. So we've got this from statement here, where we say from NGINX. Well, what does that mean? Well, what that means is this is the base image that I'm going to be pulling, right? So I'm going to pull the base NGINX image, and then I'm going to run this command here, this copy command. And all that's doing is it's taking the index.html file that's in the current working directory, and you can see I've got that HTML file there. I'll show it to you in just a second. And we're going to copy it into our containers user share NGINX HTML directory so that when we fire up this container and we go to run it, we can go to the web root and we'll hit this index.html. And then we expose, now this is important here because you're going to see this used a couple different ways. This is going to associate a specific port for a network binding. And so we're basically binding this container, and it's the internal port for the container, right? And when we go to run the container, we can use a -p option to say map this external port that we would use in the browser to get to the container's port 80 to port 80, right? And you'll see what that looks like. So again, super, super simple, 3 lines of code. This is going to build for me, and this is the power and the flexibility of building containers, is these 3 lines of code are going to pull together an NGINX web server for me that simply has the index.html page all ready to go, running internally on port 80 that we are going to then map to port 8080 on our host. Let's take a look at that index.html. Again, nothing special going on here. I modified the one that we had used in the previous 6.2.7 video. And this just says sample Docker container thing, right? And again, just being silly there. And hello world from inside my Docker container. So this is the index.html file that my Docker container is going to display to me when I hit it on port 8080. All right, so we've got the Docker file. We have our recipe to build the cake. The cake is the container. So let's go ahead and make that happen. And here's how easy it is to do that. I'm going to say docker build, build -t. Now, the -t option here is allowing me to give this image a name. And I'm just going to simply call this hello-nginx, right? And so that's going to be the name that we see and can refer to this container as later on. So the dot says, remember, the current working directory. So this is going to look at the Docker file that's in the current working directory, which we just looked at. Just those 3 lines of code is all we've got in there. And we're going to build our Docker container. And actually, before we do this, let's go ahead and say, if I say Docker PS, this is going to show me all of my running containers. If I say Docker PS-A, and I almost forgot to run these, I want to run these so that you can see that we don't have any containers running right now. And PS-A would show me all containers that are running or that are stopped, right? So PS-A is kind of like LS-A, where LS-A shows me not just all the regular files, but it's going to show me all the hidden files too. And you can think of it in this case as the -A is showing me the stopped, hidden containers, right? That I wouldn't see if I just said Docker PS. All right, so let's go ahead and let's do our, sorry, not Coker. Let's go ahead and say Docker build -t, and this is going to be hello-NGINX. And that dot says, look for the Docker file here in my current working directory. And again, we've seen what that Docker file looks like. So I hit enter and take a look at the magic that's happening here. Step 1 of 3, we're pulling down the latest and greatest NGINX image. And you can see that it's pulling it down. And the pull is complete. We downloaded a newer image, and you could actually use that syntax in the Docker file, again, trying to keep it as simple as possible. And then step 2, right? And so these steps, right? These are the recipe steps. So first step is we get the bowl. The second step is we put in some eggs. The third step is we do some flour, right? So for Docker, we're going to do our pull of the image. We're going to copy that index.html file, and then we're going to expose it internally on the container on port 80. And then my build is done. So let's clear our screen here. And now let's take a look. Let's say Docker PS. Well, it doesn't show anything. Well, remember, we're not running the container yet, right? We've just created the container. So what do we see with Docker PS-A? Again, it's not stopped, right? So we're not going to see anything here because it's not stopped. Now, what if I was to say, and there's some older school commands, you could say Docker container list, right? Which is kind of similar to the PS. So that's an old school way to do it, putting the container keyword in there. But again, Docker PS, Docker PS-A, we still don't see anything. So let's run this Docker container. So we're going to say Docker run, and here's that option I was referring to earlier, the -P. And what this says is I want to run it on my local host here, the VM that I'm running it on. I want it to be exposed on port 8080, and I'm mapping it to the container's port 80. Right? And so that's what this syntax means. You're going to see this again. Now, these values can be different. These values can also be the same. Maybe in the Docker file, I said expose 8080. If that was the case, I would do that. And all I'm saying here is, hey, on the local host, expose port 8080, and the container is exposing the container app on port 8080 as well. But we know, right, and that's why I wanted to use a different value there, is that the container exposed port 80. So all we're doing here is mapping what the container is running on port 80 to be accessible here on my virtual machine on port 8080. And that's what I'm going to hit it on in the web browser. And then we're simply going to say hello-NGINX. And this is going to be enough to fire up our Docker container. And again, I'm just checking to make sure everything's good. So yeah, we're good here. And you can see it didn't do it in the background, right? So it's running right here. So let's come over here and let me cd into test. And that was we're doing some testing there the other day. All right, so if I say Docker PS now, aha, so we are running this Docker container. And you can take a look here. It shows you the ports that the Docker container is running on internally. And then we map 8080 from the local host into port 80 on the container. Now, this is the container ID. This is going to become important when we try to stop the container or we want to remove the container. Again, that's just simply the name of the container. We've got some command notes. When it was created 19 seconds ago, the status, we're up. We've been up for 18 seconds again. So if I ran that command again, the up is now 56 seconds. So we've got everything that we need here to be able to kind of manipulate the container at this point. But the container's running, so let's check and make sure, hey, is this working? So we pull up a web browser on the local host, right? Because the container is doing its own thing. And we're going to say localhost 8080. And did it work? Take a look at that. So I've created a web server inside of a container using the NGINX image, and I copied an index.html file into that container. And that's the containers in a nutshell. Now, you might be looking at this and saying, okay, well, wait a second. Wouldn't I just use Flask to do this? And again, you could, right? But we've got bigger designs here because we're going to be rolling in that Python application. Again, this is kind of a simple, silly example of, oh, hey, here's how you would build a little web server with an index.html. And that web server is our application that runs in our container. Now, you might be wondering, and we definitely need to touch on this in terms of order of operation. So what if I decide that, I want to change the index.html? So if I say vi index.html and I come down here and we're going to go ahead, we'll put another woot woot in there. And then I save the file. Now you might be thinking, okay, well then I just go back to my web page here and I hit refresh and I should see 2 woot woots. But we don't. And that's an important aspect here. Now, we talked about mutability and immutability. Immutability, meaning something that can't be changed in place with Python, in the Python context. Here, what this is typically referred to with containers is idempotent, right? And idempotent means that I should be able to run the container over and over and over again, and it's going to do the exact same thing, right? But that we can't change it on the fly. So if I wanted to make a change like I just did right there, I can make that change, but then I'm going to have to basically bring down this Docker file here, or bring down this Docker container and recreate it and then respawn that container, because that was when I did the copy, right? Remember, when we did the Docker build command, it's going to look at that recipe. It's going to copy the index.html file over. Now, once that's done, that's it. It's done. So let's take a look at what we'd have to do in order to stop the Docker container, right? So again, if I were to say, let's come over here. If I were to say Docker PS, you can see that it's running. If I say Docker PS-A, we should see the same thing, right? Because this is the only container that's running, and it tells you that the status is up. So over here, right, we didn't do it into the background. If I do Control-C, you can see we get all this exiting stuff. So what happens if I go back to my web page now? Yeah, no, it's down. The Docker container is no longer serving things up on port 8080. So from here, if I say Docker PS, remember, this is the difference. Docker PS shows me the running containers. We don't have any containers running because we just killed it. If I say Docker PS-A, you can see right here, exited 23 seconds ago. So this container has been stopped. Now, the container ID, and let me copy this value because we're going to need it here in a second. So now I've got this container. It's like, okay, cool. Well, you know what? I want to go ahead. I want to use that new index.html. So what can we do there? Well, I can go ahead and I could have issued, actually I should have said, I could have issued a Docker stop and use the container ID. I did the Control-C because it was in the foreground there. But if it's not, I can say Docker stop. And if we were to do Docker PS-A, you can see it was stopped a minute ago and the Docker PS still shows nothing. So what if I want to remove the image, right? So I could say Docker RM and I can use that ID and I'll say paste. Now, I'm removing the container and we'll go back to Docker PS. It doesn't list. What about Docker PS-A? It's gone. So the container is no longer running. It's no longer stopped. It's been removed. And that's how that's how simple it is to create a container, runs a little web server. We got the index.html file there. Everything's looking good. And again, that single line of the copy, you could have additional lines in there. If I had built an index.html that linked to an about page, that linked to something else, I would just need the copy commands in there to copy those HTML source files into that directory so that it would do exactly what I wanted it to do. But let's go ahead and say Docker images, right? Now the PS is showing me, hey, what's running, what's stopped. Docker images is showing me the images that exist here. And so as we can see, there's my hello-NGINX image. Now, you might be looking at this and saying, wait a second, we never created anything called NGINX. Remember, when I pulled down from the Docker file, when I said from NGINX, it pulls down the NGINX image. That's where that image is coming from. But let's remove both of those. Now, the reason you might want to leave this here is that think of it as being the NGINX image, think of it as being cached. So if I'm doing a bunch of work and I'm going to use the latest NGINX image, I've already got it right here. So then I wouldn't have to wait for the from step to complete. It would check and see, hey, you've got it cached right here. So I'm going to use what we've got locally and we're going to be good to go. So how do I get rid of that? I just say RMI, remove image, and then the image name, hello-NGINX. And I hit enter. So now when I say Docker images, that's gone. So here's what we'll do. We'll leave the NGINX image here to see how it runs when I go to build my container, how it runs a little differently on the first step of the 3 steps. Okay, so again, I made my change to the index.html, brought down this container, right? Destroyed it, got rid of it, or whatever the case may be, deleted it. And so now I want to run that again. So let's say docker build -t hello-NGINX dot. And again, the dot means I'm looking for my Docker file in the current working directory. And I messed up something there because I said built, and it's funny, you know, I go to type build and I always want to hit the T before I finish there. So docker build -t hello-NGINX, and there we go. Now take a look at how much quicker step 3 ran, right? Because it knows, and if we scroll right back up here just a little bit, and oh boy, we got all kinds of error messages here. Holy Toledo. Okay, it's telling me how to run Docker. So if we look at this, take a look at this image ID right here. 3 Foxtrot 8 Alpha, blah, 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 37 Alpha 0. If we come back down here, anything look familiar right there? Yeah, 3 Foxtrot 8 Alpha and then 37 Alpha. So again, it's pulling, it doesn't have to pull down the image now. The image is there, and this is telling you, hey, that's the NGINX image that I'm using for this. Now, there's my copy command, which should have put that new index.html that I changed. We're exposing port 80. And again, we're all ready to go here. So what do? I say docker run -p 8080, and let's do 8081, right? So I'm on the local host, I'm going to access it via 8081. Internally on the container, it's just running on port 80. And then we're going to say hello-NGINX to kick it off. And again, we wanted to bring it into the foreground. We can see it here. I'm going to kill it or stop it with the docker stop ID command in just a second. We'll do a different way instead of Control-C. All right, so here we are. So 8080, I'm going to hit refresh. Yeah, no, not working. Let's change it to 8081. Whoop, whoop. All right, there we go. Hello from inside my Docker container, and you can see that the index.html file changed. So this is one of the things that is a little confusing for learners is they'll start to ask the question, well, okay, I want to change the index.html, but the changes I make don't show up here. And that's because once this container is up and running, that's it, right? For us to modify what that container's doing, we would need to bring the container down, right? Assuming you don't want the container running. We're going to bring it down, get rid of it, destroy it, RMI it, and then you can go ahead and create a new version of that container. All right, so you can see here it's running. We've even got a little log action going on here. So now I'm going to step over here and let's go ahead and clear the screen and say docker ps, and we can see there's the hello NGINX. So I'm going to say docker stop. Oh, and actually let me do this, right? So what if I tried to remove this? If I said docker remove while it's running, what do you think might happen here? I'm going to say copy because we're going to need that image ID later. You cannot remove a running container, right? So I'm glad that I clicked in my head there real quickly because this question comes up. Well, what if I try to remove it, right? If I don't want to like stop it, I just want to get rid of it. Well, we can't remove a running container. Stop the container before attempting removal or force the removal. So you could do a -F, right? But we don't want to do that. We want to do this gracefully. So we're going to say docker stop. We're going to drop the image name in here. or I'm sorry, the container ID. I think I said image name before, the container ID. And so then it stops. So we say Docker PS, it's not there. Docker PS-A, it is there. And so now we're going to say Docker RM. We're going to drop back in the container ID. So now Docker PS, it still isn't there. And then Docker PS-A, we don't see it. If I do Docker images, right, there's those two images. So let's go ahead and let's just go ahead and say Docker RMI and hello -NGINX. And here we use the name, not the image ID. And it is gone. So Docker images, right? And, you know, maybe you say, you know what, I want to make sure that I don't have too much junk laying around here. So Docker RMI NGINX, and it is gone. Docker images. And you can see it, you know, had a little bit more to do there because it was 142 megs in size. So that is it, right? That's how easy it is to work with Docker. And again, you can install Docker on your Windows box, on your Mac, on your Linux Ubuntu box if you wanted to, right? Whatever the case may be. And it allows us to create a little teeny container purpose-built to do one thing. And we've got all the bells and whistles. And again, the advantage here is imagine having to build from bare metal an Ubuntu server so that you can run the NGINX web server, right? I mean, the image is going to be huge. You're using a single virtual machine. Why not just fire up a container based on the latest NGINX image and take a look at that? 142 megs for the original image, and I think we were, yeah, right up here. And then 142 megs, that's going to be tough to compete with on a virtual system. And then you can take the container, right? And maybe you put it into what the text is going to mention at some point here soon, a Kubernetes cluster that's running. And I'm going to do a demo. I actually have a Kubernetes cluster with 4 nodes running in the AWS cloud. And we're going to see how we can take the Python application that we're going to build here as part of Lab 627. And I'm going to push that. I'm going to pull it into my Kubernetes cluster, and you're going to be able to hit that from the internet. How cool is that? And again, 142 megs. Instead of having to build a server or, again, build a huge virtual machine, there's no way that you can compete with the efficiency and the size of a little teeny container that's going to do a little web server that's going to do the same thing as Apache would do on a bare metal install. All right, I'm rambling now. So let's go ahead and wrap this up. That was our supplement for Lab 627 on how to build a simple Docker container with NGINX. We walked through all the steps to fire it up, build it, or let me get in the right order, to build it, to fire it up, to stop it, to remove it, and then to literally get rid and destroy the image, and then how we would make changes to it. Remember, idempotent, right? We can't change it on the fly. We're going to need to go ahead and make our changes, bring it down, and then bring it back up. And that also leads into a conversation on orchestration tools as to how, if we've got some version control that notices, hey, the index.html changed and it auto-magically goes out there, brings the container down, pushes that new index.html and does it all for us. And again, we're going to get to that conversation as we go. So thank you so much for watching. And as always, I hope to see you in the next video.